Far below the reach of sunlight, deeper than shipwrecks, deeper than submarines usually dare to go, lies a place where the ocean breaks its own rules. A place so strange that even seasoned deep-sea explorers hesitate before calling it real. Because down here, in the crushing blackness, where pressure could turn steel into paper, the sea holds a secret that looks impossible at first glance. A lake inside the ocean itself, complete with a smooth, glassy surface and a shoreline, as if gravity forgot where it was supposed to stop. And this is not a metaphor or an illusion created by light, because there is no light here at all. This is a real body of liquid sitting at the bottom of another liquid, a deadly mirror reflecting nothing but darkness. And the moment you realize what you are seeing, your brain instinctively rebels, because how can water exist inside water without mixing, without dissolving, without becoming one? Yet here it is, unmoving, heavy, silent, like the ocean is holding its breath around it. And this impossible lake is known as a brine pool, one of the most lethal environments ever discovered on Earth, a place where life does not struggle, does not fight, but simply ends. Instantly, because this is not ordinary seawater, this is salt concentrated to nightmarish levels, 5 to 10 times saltier than the ocean above it, and in some regions, especially in the depths of the Red Sea, over 200 times saltier, so dense that it sinks and settles into depressions on the seafloor like liquid mercury, forming stable lakes that refuse to mix with their surroundings. And anything that touches the surface learns the truth immediately, because fish do not swim through it, they drop into it. As if gravity itself suddenly increases, their bodies seizing in a violent shock as osmosis rips water out of their cells, muscles locking, gills failing, organs collapsing in seconds, and death arriving, not slowly, not painfully, but with terrifying efficiency, like flipping a switch. And the most haunting part is what happens next, because the bodies don't float, they don't decay, they sink and settle gently at the bottom of the pool, joining a silent collection of preserved corpses, a graveyard frozen in time where crabs, fish, eels, and creatures we have never even named lie scattered like forgotten artifacts, some of them unchanged for years, even decades, their shells intact, their shapes recognizable, their final moments locked in place. And this is where the paradox begins, because while these brine pools preserve organic bodies with eerie perfection, they simultaneously destroy metal, corroding steel at speeds up to 10 times faster than normal seawater, eating away at research equipment like acid, which forces a disturbing question. How can an environment that melts metal allow flesh to endure? And the answer lies in the chemistry of death itself, because these pools are not just salty, they are suffocating, completely devoid of oxygen, filled with hydrogen sulfide gas that smells like rotten eggs and kills cells on contact, methane bubbling up from the Earth's crust, and dissolved heavy metals that disrupt biological processes instantly, turning this place into a perfect storm of toxicity, a chemical execution chamber where scavengers never arrive, bacteria cannot survive, and decomposition simply stops, leaving the dead untouched, wrapped instead in mineral shells formed by barium and sulfate that crystallize around the bodies like stone coffins, sealing them away from time. And yet, even in this hellish environment, life does not completely retreat, because at the razor-thin boundary where normal seawater meets the brine, a narrow strip no wider than a few centimeters, evolution performs one of its most unsettling tricks. As specialized creatures gather along this invisible border, predators that have learned to use death itself as a hunting tool, shrimp hovering at the edge like patient assassins, waiting for unlucky fish to drift too close, knowing that once the brine does its work, the victim will float back out, stunned or dead, ready to be consumed. while nearby, pale yellow mussels cling to the seafloor, thriving not despite the poison, but because of it, hosting symbiotic bacteria inside their bodies that feed on methane and hydrogen sulfide, converting toxins into nourishment, turning what should be lethal into their own internal chemical factories. And through them, entire food chains are supported. Crabs feeding on mussels, fish feeding on crabs, even sharks passing through this wasteland to hunt. All of it balanced precariously on the edge of a lake that kills anything careless enough to cross its boundary. And this fragile ecosystem feels less like nature as we understand it, and more like a glimpse into a forgotten era. Because brine pools are not just deadly anomalies, they're windows into Earth's deep past, relics of a time when the planet itself was hostile, toxic, and alien, when oxygen was rare or non-existent, and life survived by feeding on chemicals rather than sunlight, exactly like the microbes that still exist here today, thriving in darkness, ignoring oxygen entirely, as if the last 2 billion years of evolution never happened. And standing at the edge of these underwater lakes is like standing at the edge of time itself, because this is what Earth looked like long before forests, before animals, before the sky turned blue. A planet where chemistry ruled and biology barely clung to existence. And the deeper scientists looked into these brine pools, the more unsettling the realization became. Because if life can survive here, preserved, adapted, even thriving in conditions that mimic early Earth, then perhaps these lakes are not just graveyards, but laboratories, places where the rules of life are rewritten, where death and preservation coexist, where metal dissolves and flesh endures, and where the ocean reveals that it has never been the gentle cradle of life we imagined, but a vast, ancient system capable of both creating and erasing existence without emotion, without mercy. And as researchers hovered over these silent lakes, watching bodies settle into salt-heavy darkness, one question began to echo louder than the others. If places like this exist beneath our feet, hidden in the deepest shadows of our own planet, then what else might be waiting in the dark? And more disturbingly, what might be happening down there that we have completely misunderstood? Because the brine pools were only the beginning, and the real mystery was not what they killed, but what they hinted at, a deeper secret buried beneath layers of salt, pressure, and time, a secret that suggested the ocean itself might be doing something no one ever thought possible. What unsettled scientists the most was not just that life could exist at the edge of these lethal brine pools, but that the deeper they studied them, the more the ocean began to feel less like a passive environment and more like an active system with hidden processes operating far beyond human intuition. Because these lakes were not random accidents, but the result of ancient geological events stretching back millions of years, formed when massive bodies of seawater evaporated during violent climate shifts, leaving behind thick layers of salt that were later buried under sediments and fractured by tectonic movements, allowing ultra-salty brine mixed with methane and hydrogen sulfide to slowly seep upward through cracks in the seafloor, pooling in deep depressions where its extreme density kept it trapped like liquid stone. And this realization forced scientists to confront a disturbing parallel. Because the chemical makeup of these pools, oxygen-free, sulfur-rich, hostile to complex life, was almost identical to the conditions that dominated Earth billions of years ago, long before plants ever greened the surface or animals ever breathed, meaning that the organisms clinging to survival here were not just strange anomalies, but living echoes of the planet's earliest biology, creatures that had never learned to rely on oxygen and never needed sunlight, feeding instead on pure chemistry, on reactions between minerals and fluids, as if evolution had left a door open and forgotten to close it. And yet, even this insight failed to prepare researchers for what they would discover next. Because when attention shifted away from the brine pools themselves and toward the surrounding deep sea plains, especially in the vast, silent expanse of the Clarion-Clipperton Zone in the Pacific Ocean, the rules of ocean science began to unravel completely, as measurements taken thousands of meters below the surface revealed something that should not exist according to every textbook ever written: oxygen increasing with depth, appearing in places where sunlight had never reached and photosynthesis was impossible. A finding so absurd that at first it was dismissed as equipment failure, sensor drift, or contamination, because oxygen was supposed to be born at the surface, created by algae, plants, and bacteria using sunlight, then slowly mixed downward, becoming scarcer the deeper one went as animals consumed it. But here, the opposite was happening. Oxygen levels were rising in the darkness, sometimes exceeding those at the surface, and the deeper the instruments descended, the stronger the signal became, as if the abyss itself were quietly exhaling. And this observation shook researchers to their core, because if oxygen was being produced here, in total darkness, then one of the most fundamental assumptions about life on Earth was wrong. And so the data was checked again and again, using different landers, different sensors, different deployments, until denial was no longer possible, and the phenomenon earned a name that sounded almost mythological: dark oxygen. Oxygen born without light, without plants, without life as we understood it. And immediately, the implications spiraled outward, because oxygen is not just another gas, it is the cornerstone of complex life, the accelerant of evolution, the molecule that allowed bodies to grow larger, metabolisms to run faster, and intelligence to emerge. And if oxygen could exist independently of biology, then perhaps biology did not need to create oxygen in order to thrive. Perhaps it merely learned to exploit something that was already there. And as scientists searched desperately for the source of this dark oxygen, their attention was drawn to the sea floor itself, to the endless fields of strange, black, potato-shaped stones scattered across the abyssal plains, polymetallic nodules that had quietly formed over millions of years as dissolved metals precipitated layer by layer around tiny nuclei, growing at a pace so slow that a single centimeter could take millions of years to appear. And these nodules were already famous for another reason. They were rich in manganese, nickel, cobalt, and copper, metals critical for batteries, electronics, and so-called green energy, making the Clarion-Clipperton Zone one of the most economically valuable regions on Earth, despite lying nearly 5 kilometers underwater. And when scientists began isolating these nodules in laboratory conditions that mimicked the deep sea, something extraordinary happened. Because even after sterilization, even after killing every possible microbe on their surface, oxygen levels in the surrounding water continued to rise, proving that whatever was producing this gas was not alive, not biological, but abiotic, driven by pure chemistry and physics. And this realization landed like a shockwave, because it suggested that these ancient stones were not inert, not passive, but active participants in deep sea chemistry. And when researchers measured electrical potential across their surfaces, they discovered something almost unbelievable. These rocks were generating electricity, small but measurable voltages created by redox reactions between different metals interacting with salty seawater, effectively turning each nodule into a tiny natural battery. And while a single stone produced less than a volt, clusters of them could generate enough electrical energy to split water molecules, releasing oxygen and hydrogen through a process eerily similar to electrolysis, the same reaction humans use in laboratories and industrial plants, except this version was happening silently, continuously, in complete darkness across millions of square kilometers of ocean floor. And the moment this possibility emerged, the entire deep sea took on a new identity, no longer just a place where life survived on scraps falling from above, but a vast chemical engine slowly generating energy, reshaping its own environment, and potentially supplying oxygen to ecosystems that had never depended on the surface at all, raising a question that was both thrilling and terrifying. If the deep ocean could produce oxygen on its own, independent of sunlight and life, then what role had it really played in Earth's history? And more importantly, what role might it still be playing, hidden beneath kilometers of water, pressure, and silence, waiting for us to either understand it or destroy it before we ever truly grasp what we are standing on? As Andrew Sweetman and Dr. Franz Geiger continued their deep-sea exploration in the Clarion-Clipperton Zone, they realized the stakes of human interference were greater than anyone had imagined, because beneath 5 kilometers of water lay trillions of dollars worth of polymetallic nodules, while the very same rocks were producing the mysterious dark oxygen, sustaining a fragile and unique ecosystem where 88 to 92% of species were endemic, perfectly adapted to extreme conditions, and dependent, directly or indirectly, on the chemical energy these nodules provided. Disturbing them could irreversibly destroy centuries of evolutionary development, wiping out shrimp, mussels, worms, and top predators in a cascade of extinction invisible to the surface world. And yet, mining companies, driven by greed, framed the deep ocean as an empty frontier, ignoring the delicate balance of life thriving in darkness, metabolizing methane, hydrogen sulfide, and other chemicals to survive. Microscopic architects maintaining nutrient cycles that spanned millions of square kilometers, while the production of dark oxygen, a previously unknown abiotic source, was quietly supporting life and challenging our understanding of habitability. The irony was impossible to ignore. The very nodules that represented untold wealth were also the linchpin of survival for creatures no one had seen, whose very existence depended on oxygen produced without photosynthesis. And the consequences of disrupting the system were potentially catastrophic, because these deep-sea communities recover extremely slowly over decades or centuries, meaning any damage from mining could be permanent on human scales. And as the scientists replicated these conditions in the lab, measuring oxygen output and electrical currents, they were acutely aware that back on the seafloor, dredges and drills could destroy these fragile habitats before anyone fully understood their significance. And beyond ecology, the implications extended to astrobiology. Because if oxygen can be produced abiotically in the dark ocean, life may exist in similar conditions on other worlds without sunlight, challenging decades of assumptions about habitability and photosynthesis. Yet, even as the scientists documented electrical currents and dark oxygen production, the pressure from corporations backed by governments and trillions of dollars in resources loomed over them, threatening to prioritize profit over preservation, while the scientists' work revealed that these nodules were more than mineral deposits. They were engines of life in one of Earth's most extreme and unexplored environments, a complex system linking geology, chemistry, and biology in a delicate balance that had persisted for millions of years, proving that even in total darkness, the abyss was alive, and that humanity's intrusion could have consequences measured not in years, but in millennia, emphasizing that the deep ocean was not just a frontier to exploit, but a natural laboratory, a sanctuary, and a silent reminder that life's most essential processes often happen far from our eyes, and every decision above the ocean could ripple through the depths in ways we are only beginning to comprehend. As Andrew Sweetman and Dr. Franz Geiger pushed their research further, the full scale of the abyss's mystery began to unfold, because the dark oxygen that had seemed like a hidden curiosity now revealed itself as a force that could rewrite our understanding of life on Earth and beyond. And yet, While their lab experiments confirmed that the polymetallic nodules were producing oxygen abiotically through natural electrochemical reactions, they also highlighted how dangerously close humanity was to disrupting this delicate system, as deep-sea mining operations, driven by trillions in potential profit, threatened to destroy nodules that had been sustaining life in total darkness for millions of years. And the paradox was stark. These barren-looking rocks, overlooked by the world, were silently powering entire ecosystems, enabling shrimp, mussels, worms, and microbes to thrive, connecting food chains in ways unseen by human eyes, while also forcing scientists to reconsider long-held assumptions about oxygen's origins, photosynthesis, and habitability itself. Because if oxygen could be produced in the deep ocean without sunlight or life, then the search for extraterrestrial life could no longer be limited to planets in Goldilocks zones or to surface oceans bathed in starlight. And suddenly, frozen moons, subsurface oceans, and volcanic vents across the cosmos became plausible cradles for life. And yet, amidst the scientific revolution, the reality above the ocean remained harsh. Corporations, governments, and billion-dollar lobbying efforts were determined to exploit the seafloor, often disregarding the fragile webs of life that had persisted for millennia. And the scientists knew that even a single misstep, dredging, mining, or disruption of sediment, could wipe out species that had never existed anywhere else, erasing evolutionary history and the very natural laboratory that could answer some of humanity's deepest questions. And so their work became a race against time, a battle to prove that the abyss was not empty, that it held secrets critical to understanding life, evolution, and planetary habitability, and that the Earth itself depended on these quiet, hidden processes for balance. And the deeper implication hit hard. Dark oxygen was not just a scientific curiosity, but a lifeline, a reminder that our planet's most essential systems are often invisible, and that the choices we make now about mining, exploitation, and environmental protection would echo for centuries, shaping the survival of species, the evolution of life, and even our understanding of how life could exist elsewhere in the universe. And in the end, the abyss sent a silent message through the work of Andrew and Geiger: respect the unseen, preserve the hidden, and recognize that life's most profound mysteries are often out of sight, in the deepest, darkest corners of our world. And only by protecting these places can we hope to truly understand the origin, resilience, and potential of life itself. A lesson written not in textbooks, but in the glowing, oxygen-rich rocks and thriving ecosystems of the ocean's abyss, waiting patiently for humanity to see, understand, and act before it is too late. As Andrew Sweetman and Dr. Franz Geiger prepared for their most daring descent yet, the implications of their discoveries weighed heavily on them, because the dark, oxygen-producing nodules were just one piece of a far larger puzzle, hinting at hidden chemical networks beneath the seafloor that could be shaping life in ways humanity had never imagined. And as their autonomous landers captured footage of bioluminescent creatures swarming around microelectric currents, they began to realize that these organisms were not merely surviving, they were thriving, adapting, and communicating in a world without sunlight, a world where the very chemistry of the rocks dictated survival, and every pulse of electricity, every burst of dark oxygen, every flow of hydrogen sulfide and methane was part of an intricate system millions of years in the making, yet fragile enough that a single miscalculated drill or nodule extraction could cascade through the ecosystem, wiping out species that had evolved nowhere else on Earth. And the urgency became personal when they noticed that the patterns of movement among the shrimp, mussels, and worms synchronized with subtle variations in oxygen output, suggesting a dependence so intimate it was almost symbiotic, as if the deep-sea creatures themselves were extensions of the chemical processes below. And this realization brought both awe and fear, because humanity's ambition threatened to interrupt a balance that had persisted through millennia of evolutionary pressure. And the scientists knew they were racing against both time and ignorance, trying to document, measure, and understand while deep-sea mining interests loomed over them, ready to exploit resources worth trillions of dollars, indifferent to the destruction left in their wake. And as Andrew and Geiger devised experiments to simulate nodule chemistry in controlled lab environments, they confirmed that the electrical reactions not only produced oxygen, but also created gradients that influenced microbial activity, nutrient cycling, and even the growth of new generations of life, effectively turning the nodules into living, breathing engines of the abyss. And now the stakes were global, because if these processes were interrupted, not only would the local ecosystem collapse, but the insights they offered into abiotic oxygen production, the origin of life, and extraterrestrial habitability could be lost forever. And yet, in the midst of this tension, the abyss also revealed its wonders. Phosphorescent worms curling around mineral veins, shrimp navigating microelectric fields like compasses, mussels converting toxic chemicals into nutrients, all showing that life finds a way even under the most extreme conditions, but only if left undisturbed. And as Andrew and Geiger prepared to publish their findings and warn the world, the shadow of corporate pressure, political stakes, and public ignorance loomed, a reminder that scientific discovery alone cannot protect the fragile threads of life hidden in darkness, and that preserving the abyss required more than research. It demanded awareness, regulation, and respect, because beneath the crushing weight of the ocean, in complete darkness, millions of years of evolution were teaching a lesson humanity could ignore only at its peril. And the pulse of dark oxygen, the silent electrical currents, and the thriving ecosystems of the Clarion-Clipperton Zone were speaking a message loud enough for those willing to listen. The deep sea is alive. It matters, and our actions above can determine whether its secrets endure or vanish forever. As Andrew Sweetman and Dr. Franz Dagger prepared for the next phase of their deep-sea expedition, the enormity of what they had uncovered began to crystallize, because the dark oxygen-producing nodules were not just isolated anomalies, they were part of a complex hidden system that sustained life in total darkness. And the more they observed, the more it became clear that the abyss was a living, breathing laboratory millions of years in the making, where chemical currents, microelectric fields, and toxic gases all interacted to create a fragile balance in which shrimp, mussels, worms, and microbes thrived, adapting to conditions that would instantly kill most surface-dwelling creatures. And yet, as mining companies moved closer to exploiting these polymetallic treasures worth trillions of dollars, the scientists realized that humanity was on the verge of destroying not only unique ecosystems, but also the key to understanding life itself, both on Earth and potentially on other worlds. Because these nodules and the processes around them demonstrated that oxygen and the conditions for life could exist without sunlight or traditional photosynthesis, upending long-held beliefs about habitability. And as they deployed more autonomous landers to monitor oxygen flux, electrical activity, and microbial behavior, they observed patterns that were astonishing. Creatures responding to pulses of dark oxygen, microorganisms thriving in gradients created by natural electricity, and chemical reactions sustaining food chains invisible to human eyes, all pointing to a system so interconnected that a single disruption could cascade through generations of life, potentially erasing species that had existed nowhere else on Earth. And this knowledge brought both wonder and dread, because it highlighted the delicate vulnerability of these extreme ecosystems, while simultaneously hinting at solutions for energy, chemistry, and life in other worlds. And the scientists knew that their work carried immense responsibility to document, understand, and advocate for the protection of a world that few would ever see, but which held clues to life's resilience, evolution, and potential. And yet, amidst this high-stakes research, corporate pressures loomed. Political and financial interests threatened to override science, and public awareness remained minimal, a combination that made every decision critical, because any misstep could destroy millions of years of evolutionary history in an instant. And as they analyzed the interactions between nodules, microbes, and deep-sea fauna, it became evident that the abyss functioned almost like a neural network, where pulses of oxygen, chemical gradients, and electrical currents guided life's behavior. And the scientists realized that preserving this hidden system was not just an environmental or ethical issue, it was a scientific imperative, a chance to safeguard a natural laboratory that could redefine humanity's understanding of life, evolution, and survival. And as Andrew and Geiger prepared their findings for publication, they understood the broader message of the abyss, that life persists, evolves, and adapts in the most extreme conditions, that human actions can determine whether these mysteries endure or vanish, and that preserving the abyss was essential not only for Earth's oceans, but for the knowledge, insight, and potential life this hidden world held. A reminder that some of the planet's greatest treasures are unseen, unheard, and yet absolutely vital. And as the research of Andrew and Dr. Franz Geiger pushed deeper into the abyss, the true scale of the ocean's hidden world became undeniable. Because what had started as a study of polymetallic nodules and dark oxygen had evolved into a revelation that challenged everything humanity thought it knew about life, survival, and evolution. And as their submersibles descended into trenches where no light penetrated, they saw entire ecosystems thriving in a symphony of chemical reactions, electrical pulses, and microbe-driven processes, each organism perfectly tuned to a rhythm created by millions of years of adaptation. And yet this beauty was fragile, so delicate that even the smallest mining operation could ripple through layers of life, destroying creatures, chemical cycles, and the very source of the dark oxygen that sustained them. And it was here, at the edge of human interference, that the abyss revealed its most profound secret, that life could exist entirely independent of sunlight, photosynthesis, or even traditional biological rules, thriving instead in the interplay of chemistry and geology, producing oxygen abiotically, fueling food chains, and orchestrating survival in the crushing pressure of the deep. And as Andrew documented shrimp feeding on toxic microbe blooms, mussels converting hydrogen sulfide into nutrients, and worms wriggling along nodule-generated electric currents, he realized that these creatures were not just survivors, they were teachers, living evidence that life finds a way in the harshest conditions, and that the Earth's oceans still held mysteries older and stranger than humanity could comprehend. But alongside this wonder came urgency, because corporations were drilling, mining, and exploiting the seafloor, threatening to destroy what science had only just begun to understand. And the stakes were not just ecological, but existential, for these ecosystems held clues not only to the origin of life on Earth, but to the potential for life across the cosmos, suggesting that planets, moons, or exoplanets without sunlight or atmospheres could still harbor thriving organisms. And every nodule removed, every trench disturbed, risked erasing lessons that could inform humanity's survival beyond its own planet. And in this moment, Andrew and Geiger understood that their mission was bigger than research. It was advocacy, protection, and a race against time to convince the world that these depths were not barren deserts of water and pressure, but living, breathing archives of evolution and possibility. And as they prepared to transmit their findings, including the undeniable proof of abiotically produced oxygen, microelectric networks, and thriving extreme ecosystems, they felt both hope and weight, because knowledge alone could not save the abyss, but it was the first step in awakening humanity to its responsibility. And in the silent darkness where no sunlight could reach, the pulse of the ocean told a story older than civilizations, a story of resilience, adaptation, and interconnection, where every nodule, microbe, and creature was part of a delicate symphony, a testament to life's